بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. I would like to welcome my students from grade 12 into their sixth lesson of sixth online lesson in mathematics, in which we will continue with talking about the logic problems of permutations, combinations, and the counting principle as well. So in the previous class, we have talked a little bit about we've solved some of the logical problems related to these three lessons, and we specified that in questions in which we need an arrangement, then these questions are usually solved using permutation. They can also be solved using the counting principle. And we also saw some questions in which arrangement is not important. It's only important to select a number of elements out of a larger number, and in this case we use combinations. So in this lesson we will also continue with some of these ideas, and we will explore some new ideas as well. So let's go into the examples. Let's start the first one. So in this question, the question says, in how many ways to arrange 3 males and 4 females in a straight line in the following cases: A, with no condition; B, every sex together; and C, 1 male and 1 female. Okay, so let's see. So in this question, they're basically asking about the number of ways in which we can arrange. We need to arrange 3 males and 4 females. So we will start with part A. In part A, there is no condition. So what does that mean? When we say that there is no condition, it means that we don't care if the women sit, the females sit next to the males, they sit together, the males sit together, it's mixed up, so we don't care. So in this case, we really don't care about the gender. We don't care about the sex of our people. We have 3 males, 4 females, but that is not important because there is no condition. So we deal with them as if there are only 7 people. This is what we look at the question as. So we say in this question, so if there is no condition, so there is no importance for being male or female. So we have 7 people. Okay, so we have 7 people, and this is a straight line, so 7 places, and of course it's going to be 7 options here, because I can put a male, I can put a female, there is no condition. 6 people here, 5, 4, 3, 2, 1. So the answer is going to be 7 permutation 7, or 7 factorial. So it's 7 actions and the largest one is 7, or it can be also written as 7 factorial. And here I just want to draw your attention into an important note. So let's write this note aside. So here, okay, so note. I want you always to note the following. Notice the following. The number of ways to arrange n people in places on a straight line is always n factorial. So if we have 5 people and we want to arrange them in 5 places on a straight line, the answer is 5 factorial. If we have 6 people and we want to arrange them in 6 places, then the answer is 6 factorial. If we have 7 people and we want to arrange them in 7 places, the answer is 7 factorial. This is always the case. So, and this is the answer to part A. Okay, let's see. So in part B, in part B, they say that they want to arrange them, but this time they want to arrange every sex together, every gender together. So they want the males together and they want the females together. So let's see, how do we do that? So how many males do we have? We have only 3 males. So let's say that this is 3 males, and then we have 4 females. So let's say that this is 4 females. So this is females. So they are together, and in the same way, the males are together. So this is one way to put it. We put the 3 males first, and then we put the 4 females after that. Or there is also another way, which is you put the 3 males at the end. So these are the 3 males. And then you put the 4 females at the beginning. So this is the 4 females. So we actually have 2 ways to do it. Either putting the males first and then the females, or doing the opposite. If we put the males first, then here we have 3 options, 2 options, 1 option. The females, we have 4, 3, 2, 1. And the answer is going to be 3 factorial multiplied by 4 factorial. Or, we said that or translates into addition. So this is plus. So plus, if we put the females together, then we're going to start with 4, 3, 2, 1. And then the males are going to be 3, 2, 1. So the answer here is going to be 4 factorial multiplied by 3 factorial. And when we add these 2 together, we're going to get 2 times 4 factorial times 3 factorial. And this is going to be our last answer. In the previous class, we've seen that this answer can be written in many ways. We can write it as, so the answer, we can write it as 2 factorial times 4 factorial times 3 factorial. Or we can write it as 2 permutation 2 times 4 permutation 4 times 3 permutation 3 is also correct. Or we can write it as maybe 2 permutation 1, because 2 permutation 1 or 2 permutation 2 is the same thing. This is 2 and this is 2 times 4 permutation 4 times 3 permutation 3. It doesn't matter really how do we write it, as long as we get the same answer from each one of them. If you try to evaluate each one of these different answers, you'll get always the same answer. And that's why all of these answers are correct. So let's see now. Let's try to solve part C. Okay, so in part C, they want 1 male and 1 female. 1 male and 1 female. So how do we do that? 1 male and 1 female. Let's see. So we have only 3 males. So let's put the 3 males here. 3 males. How many females do we have? We have 4 females. So is it possible to start with a male? If we start with a male and then a female, a male and a female, a male and a female, and then I have 1 more female, I cannot put her here, because if we put her here, we're going to have 2 females next to each other. So the only way to do it is to put the female here at the beginning. So we have a female, 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 and then we're going to have the males in between. So we have the male here, male, and male. So we only have 1 way to do this one. There is no or, there is no other scenario. There is only 1 scenario, which is you put the female first and then you put the males. So let's do this. So if we do that, so what are we going to have? We're going to have 4 options for females, reducing into 3, and then 2, and then 1. For the males, we're going to have 3 options, and then 2, and then 1. And the answer is going to be 4 factorial, 4 factorial, this one here, is 4 factorial. Let's see. So 4 and 3 and 2 and 1, that's 4 factorial, and then it's multiplied by 3 factorial. So we have 3 and 2 and 1. So the answer is going to be 4 factorial multiplied by 3 factorial. So it's 4 factorial multiplied by 3 factorial. And the answer, maybe we can evaluate the answer sometimes. You can have the answer like 24 times 6, and this is 120, 144. So 144. You can have the answer as 144. You can have the answer as 4 factorial, 3 factorial. You can have the answer as 4 permutation 4, 3 permutation 3. They're all possible ways to write the answer, and they're all accepted. So in this question, we mainly used the counting principle, which translated into factorials or permutations. They're both correct. Well, I hope you understand this one well, and let's move on to another one. So here. Okay, so let's check the second question together. In this question, the question says the following. We have an administrative board, which is composed of 6 members. So what we care about really here is the number here, 6 members. We have 6 members. And from this 6 members, the question is in how many ways can we choose a chairperson? So we have a chairperson, secretary, and an accountant. So we're going to choose 3 people out of 6. The question now, when we choose them, is it important to arrange them after we choose them or not? In the previous class, I think I told you that if we assign people to different responsibilities, then you need to arrange them. If I'm going to select A and B and C out of A, B, C, D, E, F, I have 6 people, A, B, C, D, E, F. If I'm going to select A and B and C, I have to specify who is going to be the chairperson. Is it going to be A or B or C? Who is going to be the secretary? Is it going to be B or C or A? Who is going to be the accountant? Is it going to be C or B or A? So you have to arrange them. After you select them, you have to arrange them to put 1 as the chairperson and 1 as the secretary and 1 as the accountant. So the arrangement is really important. And whenever the arrangement is important, what we use is a permutation, not a combination. So the answer to part A is going to be 6 permutation 3. There are 6 people, and we're going to choose 3, but not only choose them, we're going to select them and then arrange them. So we're going to choose and arrange. So to solve this, we're going to write 3 actions, and the largest action is 6, so it's going to be 6 times 5 times 4. The answer is 20 times 6, which is 120. So you can have this answer in the multiple choices or that answer. They're both good. So this question was a permutation question because arrangement was important. Now let's look at the second part. In the second part, in part B, it says in how many ways can we select 3 members, 3, without assigning them to any tasks. So we're going to select 3 members, but we're not going to give them any tasks. So these members are going to be equal in responsibility. They don't have anything to do. They have the same responsibility. And if they have the same responsibility, it's not important whom you choose first or whom you choose second or whom you choose third. In other words, arrangement is not really important. And if arrangement is important, it's a combination. So this is combination 6-3, which is evaluated as 6 permutation 3 over 3 factorial. 6 permutation 3 is 6 times 5 times 4. And 3 factorial is 3 times 2 times 1, which is not important. You cancel 3 times 2 with 6 because they're both 6. You get 5 times 4, which is 20. So the answer to part B is 20. It's always true, that combination NR is less than permutation NR for the same N and R. So permutation 6-3 is more than combination 6-3. We're the opposite. Combination 6-3 is always less than permutation 6-3, and this is true for any two numbers. Okay, so let's see another question. So the third question. Here it says, in how many ways can we form a committee that is composed of 4 managers, at least among 6 managers? Again, what we care about is the idea. Here we want to make 4 managers, at least among 6 managers. Okay, at least is a key word. So what do we want? Do we want to select or do we want to arrange? Here it's only 4 managers. Do they have the same responsibility? Yes, they have the same responsibility. We don't have different responsibilities. We don't have different positions. And that's why it's going to be a combination. So we want to select, we want to choose, we can say, choose 4 out of 6, right? At least, or 5 out of 6, or 6 out of 6, because we want 4 at least. So 5 is good, 6 is good. So the answer to this is going to be combination 6-4, or is translated into addition, combination 6-5, or combination 6-6. Okay, combination 6-4 is the same as combination 6-2. Using the reduction formula. Combination 6-5 is the same as combination 6-1. Using the reduction formula. Combination 6-6 is just 1. Combination 6-2 plus combination 6-1 is combination 7-2. Using Al-Kirchi's relation plus 1. So the answer is going to be 7 permutation 2 over 2 factorial. This is the answer of the combination plus 1. We can say it is 7 times 6 over 2 times 1 plus 1. We cancel the 2 with the 6, we get 3. So it is 7 times 3, which is 21 plus 1, and the answer is 22. So we have 22 different ways to choose 4 managers, at least, out of 6 managers. So the next question says, in how many ways can we select a soccer team composed of 11 players among 15 renowned players in the game? We don't really care about the structure of the question. What we care about mainly is the main idea. I want to choose 11 players out of 15 players, and it's a soccer team. And in the question, they did not say any responsibilities. They did not state any responsibilities, so we just assume all of them have the same responsibility. So in this case, it's a combination, not a permutation. It's a combination of what? It's a combination of 15, and we want to choose how many of them? We want to choose 11. So it's 15 combination 11. There is no at least, there is no at most, no keywords, only one choice. And using the reduction formula, this is going to be the same as combination 15-4, which is going to be the same as 15 permutation 4 over 4 factorial. 15 permutation 4 is 15 times 14 times 13 times 12 over 4 factorial is 4 times 3 times 2. We can do some cancelling now. So let's see. We can cancel 4 times 3 is 12 with 12. We can cancel 2 with 14. We'll get 7. So we have 15 times 13 times 7. Well, 15 times 13 is 195. 195. And 195 times 7 is going to be 1,375. 1,375 or 65, because it's 35. Yes, it's 65, sorry. So this one is 1,375 365. Okay, so this is the number of ways in which we can do this. It's 1,365 ways. Of course, guys, you can have this final answer as 1,365 in your answers, or you can have this one, which is 15 combination 4. Sorry, this one, or you can have this one. Any one of the choices is good. Okay, so do not limit yourself to one answer only. Let's carry on. The next question says the following. Among 10 teachers and 20 students, it is desired to select 2 teachers and 3 students to represent the school in a festival. In how many ways can that be done? Okay, let's now look at the numbers. 10 teachers, I have 10 teachers and I want to select 2 teachers out of them. So from 10, I want to select 2. And 20 students, I want to select 3 students. This is not a seating question. I'm not going to seat them. We're going to select. And if we select them, then are they going to have different responsibilities? Is the arrangement important? In other words, no. The arrangement is not important. What do we want? We want to choose, simply, we want to choose 2 out of 10 teachers. And we want to choose 3 out of 20 students. This is basically what we want to do. 2 out of 10 teachers and 3 out of 20 students. This is what we want to do. So as long as it's choosing without arrangement, it's going to be a combination. So it's going to be a combination of 10 and we want to choose 2. And here translates into multiplication. So or always translates into addition. And always translates into multiplication. So these are 2 different operations, and this is how we represent them. So we want to choose 2 out of 10 and here and 3 students out of 20. So and we want to choose out of 20 students, we want to choose 3. Okay, so this should be our answer. How do we simplify this? It can be 10 permutation 2 over 2 factorial multiplied by 20 permutation 3 over 3 factorial. We solve that, so it's 10 times 9 over 2 multiplied by 20 times 19 times 18 over 3 times 2. We cancel what's possible. We can cancel 3 times 2, which is 6, with 18. We get 3. We can cancel 2 with 20. I can get 10. Or 2 with 10, no problem. But I prefer the 10s. So what do we have now? We have 3 times 9. 3 times 9, which is 27. Times 19. So it's 27 times 19 is 513. So it's 513. So 513. And then we have a 0, another 0. Why? Because it's times 10 times 10. So the answer is going to be 10 times 9 times another 10 times 19 times 3, which is 51,300. Of course, you can calculate this number at your own pace using whatever methods you like, and this is going to be our final answer. You can have this answer in the choices, or you can have this answer in the choices, and they're both good. I hope this one is clear. Let's move on. So this question says the following. It is desired to found a physics society in a school that is composed of 3 teachers and 5 students. Again, what we care about is the numbers. 3 teachers, 5 students. Among 8 teachers and 11 students. That's what we care about. I want to select 3, so we want to choose Again, no arrangement, because there is no arrangement because there are no different responsibilities. They all have the same responsibilities. So we want to choose 3 out of 8 teachers, and we want to choose 5 out of 11 students. So this is going to be 8 combination with 3 and translates into multiplication, as we said earlier in the previous example, 11 combination 5. We can have this answer in the choices, or it can be the simplified version. So it's 8 permutation 3 over 3 factorial times 11 permutation 5 over 5 factorial. Let's do this. So this is going to be 8 times 7 times 6 over 3 times 2 times 11 times 10 times 9 times 8 times 7 over 5 factorial, which is 5 times 4 times 3 times 2 times 1. We can cancel the 5 with the 10, we get 2. We can cancel the 4 with the 8, we get 2. We can cancel the 3 with the 9, we get 3. We can cancel the 2 here with the 8, we get 4. We can cancel the 3 with the 6, we get 2. We can cancel the 2 with the 4, we get 2. So the answer is going to be 2 times 7 times 2, which is 14 times 2, which is 28. So 28 times 11, which is 308. 308 times 2 times 3 times 2 times 7. So 308 times 12 times 7 is going to be 25,872. So this is going to be our final answer. You can have this answer in the choices, or you can have that answer, but most likely with numbers like this, big like this, you will have this answer in the choices. Most likely it's this answer in the choices. Let's carry on. So the next question says the following: in how many ways can we form a committee in a factory consisting of 7 members, elected among 9 female workers and 5 male workers? Okay, let's pay attention to this one. 7 members. I have 9 female workers and 5 male workers, and we want 3 males only, and it's 7 members. So if it is 7 members and we want 3 males, so for sure we have 4 females, right? If it's 3 males, then it's for sure 4 females. So what do we want to do here? Do we want to arrange? Do we have an arrangement? No, we don't. We want to choose. What do we want to choose? We want to choose 3 males out of 5, because we have 5. And we want to choose 4 females. Let's erase this. So we want to choose 4 females. 4 females out of 4 females out of 9. Okay, so it's a combination. So it's combination 5, 3, and multiplication combination 9, 4. This one can be reduced. It is combination 5, 2, which is lower, times combination 9, 4. So combination 5, 2 is 5 permutation 2 over 2 factorial multiplied by 9 permutation 4 over 4 factorial. And this is going to be 5 times 4 over 2 times 1 times 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1. And we cancel. We can cancel the 9 with the 3. We get 3. We can cancel the 4 right away with the 4. We can cancel the 2 with this 8. We get 4. And the other 2 with this 6. We get 3. So the answer is 21 times 12 times 5. 21 times 5 is actually 105, and 105 times 12 is 1260. You can have this answer in the choices, you can have this answer in the choices, or that answer. They're all correct. Okay, now let's look at a new idea. Here, it is desired to arrange. So there is the arrangement. 9 cars among which 2 are red, 3 are white, and the rest are of different colors, other than white and red. In how many ways can this arrangement be done? This is an important question because here we'll be discussing an important thing. Yes, we want to arrange 9 cars. The question says arrangement, so it should be permutation, but actually it is not permutation. It's not purely permutation. It is permutation with combination. How is that? Look, we want to arrange 9 cars in which 2 are red. Okay, so 2 cars are red. Does it matter if we put them in this order or do we put them in the other order? Are these 2 different orders or it's the same order? I mean, if we put the first car here and the second car here, they're 2 red. Or we put the second and the first, they're both red. They're both the same car. They're identical cars. They're identical cars and they have the same color. So if we put them in this order or in that order, it doesn't matter. It's not different actually. And since here, so between the red cars, arrangement is not important. Here, arrangement is not important. 3 white, okay, the same thing here. 3 white, we have 3 white cars, white, white, white. Do you know which one is the first or the second or the third? No, it doesn't matter. Is this a different order? No, it's the same order. I just don't know. It doesn't matter. They're 3 white next to each other. So here, 3 white cars. It doesn't matter how do you put them in. It doesn't matter how you put them in which order because it's going to be the same thing. It's going to be the same thing. So this is a combination scenario. When arrangement is not important, it's a combination scenario. So where is the permutation? The permutation is which color do we start with? Do we start with white and then red and then the other colors? Or is it red and then white and then the other colors? Or is it one of the other colors and then red and then another color and then white? So there is an arrangement between the colors themselves, but inside the color, inside each color, arrangement is not important. This case of permutation and combination together can be solved using the 2 different approaches. So approach number 1, and you get the same answer in each case. What do you do? In approach number 1, you say the answer is the following. So we want to arrange 9 cars in which we have 2 red. And then, after you arrange the red, you get 7 cars. You will select from them 3 white. And then, after you take the 3 from the 7, you will get 4 cars. You will arrange the first color because each is a different color, and then 3 1 color, and then you take 2 1 color, and then 1 1. This is one way to do it. So we have 9 cars. We take the first color, which is the red. And then we have 7 cars. We take the second color, which is 3. We're left with 4 cars. We take the first color and then the second, the third, the fourth. This is one way to do it. Or approach number 2. Approach number 2. You can do this combination, this special combination. You can write that this is a combination of 9, and then you write here 2, 3, 1, 1, 1, 1. This is 9 and that's 9. Okay. We know how to evaluate this one, but we don't know how to evaluate the second one. Let's see how do we evaluate each one of them and if we get the same answer. And after this question, we'll see some other questions that are similar to this one so that you get the idea when do we use these two approaches exactly. Here is going to be 9 permutation 2, which is 9 times 8 over 2 factorial. 7 permutation 3, which is 7 times 6 times 5 over 3 factorial. Combination 4 1 is 4, combination 3 1 is 3, combination 2 1 is 2, combination 1 1 is 1. We cancel what's possible. 2 with 8, we get 4. 3 times 2 with 6. So the answer that we get is going to be 9 times 4, 9 times 4 times 7 times 5 times 4 times 3 times 2. 9 times 4 is 36. 36 times 35, then times 4 times 3, which is 12, times 2, 24. The final answer is going to be 30,240. So this is one way to do it. The other way here, how do we evaluate such a combination? Well, let's look at this note. So here, note, combination n r1, r2, r3, etc. is evaluated as follows. It's n factorial over r1 factorial times r2 factorial times r3 factorial and so on. So what do we mean by that? Let's see here. So this is equals to 9 factorial over 2 factorial times 3 factorial times 1 factorial. How much is 1 factorial? It's 1. So 1 factorial, 1 factorial, 1 factorial, 1 factorial does not matter. So it's equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 2 factorial, which is 2 times 3 times 2. Look, 3 times 2 is 6. Cancel it with 6 and cancel the 2 with the 8. We get 4. We get the same thing here. 9 times 4 times 7 times 5 times 4 times 3 times 2 times 1. It's the same string of numbers, and it gives you the same answer, 30,240. So this way is actually used, or we can use this way whenever we have more than one R for the same n. Let's check another question similar to this one. Let's see. So here, 15 students are to be distributed among 3 groups, consisting of 8, 4, and 3. So there are 15 students, and we want to divide them into 3 groups. And the first group is 8, the second group is 4, so this is 12, and then 3 students, so it's 15. In how many ways can that be done? Is arrangement important? It's important and not important. How? Let's take a scenario of a student. His name is Ahmed. If we select Ahmed among the first 8 people, he's going to be in the first group. If we select him after the first 8, he's going to be in the second group or in the third group. So arrangement is important. Where do we select Ahmed is important. But if we select him, if he is the first one to be selected, or he is the second one to be selected, or the third, or the fourth, or the fifth, or the sixth, it doesn't matter up to the eighth, because they are all in the same group. So it matters if we select him after the eighth, because he is going to be in a different group. But in the first 8 doesn't matter, because he is going to be in the same group. So the point is, if this is the first group, and this is the second group, and this is the third group, if Ahmed is the first one here, or he is the third one, or he is the fifth one, it doesn't matter, because he is still in the same group. From 1 to 8, he is still in the same group. After we select the 8th one, we're going to move to the second group. So he's going, if we select him after the 8th, it will matter for him, because he is going to be in a new group. He is going to be the 9th in the second group, or the 10th, or the 11th. But it doesn't matter if he is the 9th, or the 10th, or the 11th, or the 12th, because he is still in the same group. If we select him after 12, it matters for him, because he is going to be in the third group, whether 13 or 14 or 15. So the point is, inside each group, the order is not important, but it's important between the groups themselves. So maybe this group, for example, is responsible for playing soccer. Maybe this group is responsible for art. Maybe this group is the group of music. So if we select them first, he is going to play soccer. If we select him second, he is going to go into art. If we select him third, he's going to go into music. So it matters for him. He has different responsibilities in each one of them. So there is permutation among the groups, but inside of each group, there is no permutation, there is combination. So this is a question in which we have a mixture of the two. And whenever we have a mixture of the two, there are 2 ways to do it, or 2 approaches. It's exactly the same as the previous question. So the first way to do it is, you say it's a combination of 15, you take 8 out of them, and then if you take 8 out of 15, you still have 7, you take 4 out of them. If you take 4 out of 7, you get 3, and you arrange the 3, or you select the 3. So this is one way, or the other way is going to be combination of 15, and here 8, 4, 3. How do you open each one of them? You can reduce this. So this is 15, 7 after reduction, and reduce this. This is 7, 3 after reduction, and combination 3, 3 is 1. So after that, what do you do? This is 15 permutation 7. So it's 15 times 14 times 13 times 12 times 11 times 10 times 9 over 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 7 times 6 times 5 over 3 times 2 times 1 times 1. And then you start cancelling. You can cancel the 5 with the 15, you get 3. You can cancel the 7 with the 14, you get 2. You can cancel the 6 with the 12, you get 2. You can cancel the 4 with the 2 here and the 2 here. You can cancel the 3 with the 9, you get 3. You can cancel the 2 with maybe the 10, you get 5. You can cancel the 3 with the 2 with the 6. So you end up with what? You end up with 3 times 13 times 11 times 15 times 35. And can use a calculator for this one, honestly. So it's 3 times 13 times 11 times 15 times 35. So I'm going to get 225,225. Okay. So this is one way to answer it. Or we can do the other way, which is 15 factorial over 8 factorial times 4 factorial times 3 factorial. We should get the same answer, which is 225, 225. And I encourage you to do this one. This is usually a lot faster than the first one. You can have this answer in the choices. You can have this answer in the choices. They're both possible. Okay? But for such big numbers, it's not likely that you get this answer in the choices. Let's do a similar question. Let's see. So in how many ways can 2 committees be elected where each one of the 2 committees consists of 4 members? If we have 10 individuals to elect from, and where no one of the 10 can be elected in both committees at the same time. Okay, so we want to have 2 committees. Each one has 4 members. Okay, so we're going to choose, right? We're going to choose 4 members out of the 10. And then after we choose, this is going to be the first committee. First group. Committee means group. Times, after we choose the first committee, we will be left with 6 people because we cannot choose someone in both groups. So we're going to be left with 6 people. We want to choose 4 out of them. And this is going to be our second committee. So it's going to be like this. 2 committees, each one of them is 4 members. There is an and between them because I want to select the first committee and the second committee. The first committee is 4 out of 10 and the second committee is 4 out of 6. So the answer is going to be, after reduction, 10 4 times 6 2 after reduction, which is 10 permutation 4, 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1, which is 4 factorial, times 6 times 5 over 2 times 1. We can cancel the 4 with the 8. We get 2. The 3 and the 2 with the 6. The 2 with the 2. So what are we left with? We're left with 7 times 5, which is 35. 35 times 9, which is 315. 315 times 10, which is 315, 0. So 3,105. Let's see the next question. In how many ways can we rearrange the letters in the word Mississippi? Okay, this is a common question in the ministry exams. It's common that they give you a word with repeated letters and they ask you to rearrange the letters in this word. And this is the same case of the previous case. Whenever you have a word with repeated letters, then what I advise you to do is the following. First of all, count all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11 letters, right? There is the letter M, and it's repeated once. There is the letter I. It is written 1, 2, 3, 4 times. There is the letter S, which is 1, 2, 3, 4 times. And then there is the letter P, which is 2 times. Right? So how do we rearrange these letters? It's the same as the cars and the colors. It's like you have 9 cars and 2 red and 3 white. It's the same thing. So the answer is going to be 11 combination of 1, 4, 4, 2. And this is going to be 11 factorial over 1 factorial times 4 factorial times 4 factorial times 2 factorial. And whatever the answer is, this is should be your final answer. Let's see. It's 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. I'll stop here. Over 4 factorial times 4 times 3 times 2, which is the other 4 factorial, times 2 factorial, which is 2. The 1 factorial is 1. I can cancel the 4 factorial with the 4 factorial. I can cancel the 4 with the 8. I get 2. I can cancel the 3 with the 2 with the 6. I can cancel the 2 with the 2. So I get 7 times 5, which is 35, times 10, which is 315, times 10, times 9, I'm sorry, times 10, which is 3,150. 3,150 times 11 is 31,500, 34,650. So it's going to be 34,650. So you can actually have this one in the choices, you can have this one in the choices, or maybe this one. They're all right. And whenever the question is about rearranging the letters of a word, and in this word you have repeated letters, this is the only way you do it. Look, in how many ways can we rearrange the letters in the word essential? Same thing. So essential, E-S-S-E-N-T-I-A-L, 9 letters. 9 letters. Okay, the letter E is repeated 2 times. The letter S is repeated 2 times. The letter N is 1 time. The letter T is 1 time. I-A-L, 1 time, 1 time, 1 time, 1, 2, 3, 4, 5, 5 and 4 is 9. So this is going to be combination of 9, and here 2, 2, and the rest is ones, and the ones are not important because 1 factorial is 1. So it's 9 factorial over 2 factorial times 2 factorial, which is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial times 2. 2 factorial cancels 2 factorial. 2 cancels 4, for example, we get 2. And then we multiply the rest of the numbers. I'll use a calculator for this one. I have 9 times 8 times 7 times 6 times 5 times 2 times 3. And the answer is 90,720. 90,720. Most likely, this is what you're going to have in the choices, or maybe this one. I hope this is clear so far. If you have any questions, please send me via WhatsApp, and I'm going to be more than happy to answer these questions. Let's look at a new type of questions. And this is the third type and the last type. So here, in how many ways can a student choose 5 questions to answer in a test that is composed of 6 questions, and where the first question is compulsory or mandatory? Compulsory or mandatory means that you have to select it. You have to choose it. You have to choose that question. So this question is composed of 6. This test is composed of 6 questions. 6 questions. 1, 2, 3, 4, 5, 6. You have to choose this one. This one you have to choose. So you are actually free to choose. Your freedom is not in selecting 5 questions. You don't choose 5 questions. Actually, you're going to choose 4 questions. Why? Because this one was chosen for you. They have chosen the first question for you. So you can't say that I chose 5 questions. What you actually chose is 4 questions. Out of how many? Out of 5. So in this question, you're going to choose 4 out of 5. Not 5 out of 6, no. You're not going to choose 5 out of 6 because the first question is already chosen for you. You're free to choose only 4 out of 5, and the answer is 5, 4. After reduction, this is 5, 1, and which is 5. So you can have either of the 3 in the choices, and this is the answer of this question. Let's look at a similar question here. In how many ways can we elect a committee of 8 members among 8 teachers and 15 students, so that the committee consists of 5 students and 3 teachers? No, this is not a similar question. This is a question that we solved like before. we elect a committee of 8 members. 8 members among 8 teachers and 15 students, and the committee consists of 5 students and 3 teachers. So how do we solve this? We have seen a question like this, so here we leave this as homework. Please try to solve this one and send it to me. I think it's an easy question. Let's look at a question that is similar to the previous one. Here. No. The physical education teacher would like to divide the students of a class consisting of 20 students into 3 sports teams. Basketball team consisting of 5 players, so there are 20 students. He wants 5 players in basketball and 11 in gymnastics, so this is 16. And 11 in the soccer team, in the soccer 11. And in the gymnastics, he wants 4. So 5 and 11, which is 16, plus 4, 20. In how many ways can this division be done? So we have 20 students, and I want to select from these 20 students, I want to choose 11 and 5 and 4. I'll leave this also as homework for you because I've solved a question like this. And let's see the next question. In how many ways can we select 10 workers to work in a factory among 12 applicants in the following cases? So I have 12 applicants and I want to select 10 workers without any condition. So if it's without any condition, it's a combination of 12, 10. We want to choose 10 out of 12, which is going to be the same as 12, 2, which is going to be 12 times 11 over 2 times 1, which is going to be 66 ways. That's the answer to the first question. In B, a certain applicant must be chosen. So there are 12 applicants, one of them you have to choose. So he is chosen for you. If he is chosen for you, it means that you're not going to choose out of 12. You're going to choose out of 11, and you will not choose 10, you will choose 9. So we have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They told you that this one you have to choose. So this one is chosen. So you're free to choose 9 out of 11. Not 10 out of 12, because they chose one for me. So it's only 9 out of 11. So this is combination 11, 9, or the same as combination 11, 2, which is 11 times 10 over 2, which is 55. The third one, they say a certain applicant must be disregarded. We have to ignore him. There's an applicant that we have to ignore. So in this case, this first one is going to be ignored. So you're not going to select 9. You still have to select how many? You still have to choose 10. But this time you'll choose 10 out of how many? Out of 11. So in part C, you'll choose 10. There are 11, and you'll choose 10 out of them. So you'll choose 10 out of them. So it's going to be combination 11, 10, which is the same as combination 11, 1, which is 11. So there are 11 ways to do it. Okay, I hope this one is clear. Let's do this next one. Okay, this is the last question here. It says the following. A society of math consists of 10 students. So we want to choose 3 students to be in the committee that represents the school in general math competition in the following conditions. 2 students must be in the committee together. What does that mean? It means that we have to choose these students. If I choose one of them, I have to choose the other one. They have to be together. They must be in the committee together. They don't say they must be in the committee and must be together. No, they say they must be together. So if we choose one of them, we have to choose the other one. Let's picture this question. So there are 10 students. This is 10 students. Oh, I'll take forever drawing 10 sticky figures. Let's do another thing. So 10 students. Let's say that we have 10 students. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now they say that these 2 students, if I choose one of them, I have to choose the other one. But I have 2 choices. It's either, and remember that I want 3 students, okay? So either choose the 2 students and then 1 out of the 8, because I still have 8 here. And these are 2 students. So either choose the 2 students and then choose 1 out of the 8, so I have 3 students, because I need 3 students. Or since these 2 students are giving me headache, I can just ignore them, or I will choose the 3 out of the 8, right? Or choose 3 students out of 8. So just ignore the 2 students who want to be together. So they want to be together. Either choose them together and choose 1 student from the rest, which is 8, or just ignore them and choose the 3 from the 8. So you have 2 choices. Either choose 2 students out of 2 students, here 2 students out of 2 students, and multiplication 1 out of 8, or is addition. Choose 0 from the 2 students, don't choose them at all, and choose 3 from the 8. So that's the answer to the first part, part A. 2 out of 2 is 1, 8 1 is 8, or 2 0 is 1, and 8 3 is 8 times 7 times 6 over 3 times 2 times 1. So the answer is going to be 8 plus 8 times 7, which is 56, and the answer is 64 ways. This is part A. Part B. 2 students are forbidden to be in the committee together. So they can't be in the committee together. If I choose one of them, I can't choose the other one with him. So again, either choose 1 of the 2 and 2 out of 8, or ignore them. Choose 0 of them. Choose 0 of the 2 and 3 out of 8. So logically we can do just either this or that. So either choose 1 of the 2 and 2 of the 8, or choose 0 of the 2 and 3 of the 8. So choose 2 of 1 is 2 times 8 2 is 8 times 7 over 2, or 2 0 is 1 times 8 3, we've just did 8 3 before, it got us 56. So here we cancel 2 with, we get 4, 2 times 4 is 8, 8 times 7 is 56, so it's 56 plus 56, and the answer this time is going to be 112. This was a ministry question, I think in 2007, 2008. And with this question, we will finish today's lesson. I wish that you have a good picture about this part. I encourage you to repeat this video and the previous video twice or 3 times in case there is anything that is not clear, because these logical problems, they can be a little bit tricky, but with time and with the right amount of exposure, I'm sure that you will do just fine. I also hope that you do the homework, and I'll see you tomorrow. I'll see you inshallah in the next video, in which we will talk about the the binomial theorem, which is the last lesson in this unit. I wish you all the best of luck. Stay home, stay safe, study hard.